A widely used discrete. A widely used discrete probability distribution is called the binomial distribution. In fact, the example of tossing a coin 3 times is an example of a binomial distribution. Characteristics of the binomial distribution. 1. There must be a fixed number of trials denoted with the letter n. In our coin toss, n was equal to 3. 2. There are only 2 outcomes per trial: success or failure. In our coin toss, we had either heads or no heads. The outcome of each trial are independent. The outcomes of each trial are independent of each other. That means one event does not affect the other event. The outcome of one toss does not affect the outcome of another. 4. The probability of success P must remain fixed from one trial to another. In our coin toss, the probability of heads is 0.5 on each trial, and it never changes. Here, the probability of success is denoted with the letter P. In a binomial experiment, the probability of obtaining exactly X successes in n trials is given by the following formula. P of x equals n choose x times p raised to the x power times the quantity 1 minus p raised to the n minus x power. Notice we have n choose x here, and that's going to be done on your calculator. You could watch an earlier video and I show you how to use combinations on the calculator. Now the variables in the formula are the following. N equals the number of trials. X equals the number of successes. And P represents our probability of success. We will try some problems by hand, and some problems will be done with our statistics calculator. A link will be provided in the description. Since P is the probability of success, what do you think 1 minus P represents? 1 minus P is exactly the same as our complement rule. 1 minus P is the probability of failure. The probability of failure is represented by 1 minus P. To use this formula to calculate the probability of X, we need N and P, the probability of success, on a single trial. P will be a probability, a percentage, or a proportion. Example. We toss a biased coin that turns up heads 60% of the time. We toss the coin 5 times. Find the probability of obtaining exactly 2 heads. We have the probability of success is 60%. So that's going to be my P. And I want to convert that to a decimal. So let's say 0.6. We're going to toss the coin 5 times. That's going to be N. And now we need to know how many success we want, and we want exactly 2 heads, so X is going to be equal to 2. Let's recall our formula. P of X equals N choose X times P raised to the X times the quantity 1 minus P raised to the N minus X. In our case, we want X to be equal to 2, so I'm going to plug in that 2 for our X values, and our N is going to be 5. So P of 2 equals 5 choose 2 times p, which is 0.6 raised to the second power, times the quantity 1 minus 0.6 raised to the 5 minus 2 power. I always like to simplify each part separately, then I'll do the whole thing on a calculator. 5 choose 2 is equal to 10, and 1 minus 0.6 is 0.4, and 5 minus 2 is just 3. Now this is easy to type in a calculator, so we'll type in the whole expression in a calculator, and we'll calculate our probability. This gives us a probability of 0.2304. So we have about a 23.04% chance that we're going to get exactly 2 heads from a biased coin. If you have trouble finding 5 choose 2, refer back to our past video on how to calculate with a calculator. Example. Discovery research found that 40% of Americans do not think that having a college education is important to succeed in the business world. If a random sample of 12 Americans is selected, find the probability that A. Exactly 3 of them agree with this statement, B. At least 3 agree with this statement. We'll always start by looking for N, P, and X. In our first situation here, we have P is 40%, so we'll say 0.4 in a decimal. N is 12 because we want to pick 12 Americans, that's 12 trials. And for part A, we want exactly 3 of them to agree, so X is exactly equal to 3. Recall the formula again. P of X equals N choose X times equals P raised to X N choose X, so that's 12 choose 3 times P raised to the X, or 0.4 raised to the third power, times the quantity 1 minus P, or 1 minus 0.4 raised to the N minus X, or 12 minus 3. So we're just simply plugging in each corresponding value to the corresponding letters. Now 12 choose 3 is 220, and do that using your calculator. 0.4 cubed is now multiplied by 1 minus 0.4 is 0.6, and that's raised to the 12 minus 3, or just 9. And using our calculator, this gives us a probability of 0.1419. If I round this to 4 decimal places, I get 0.1419. So we have a 14.19% chance that exactly 3 Americans will agree with the statement if 12 Americans is selected. Let's try part B. In part B, we have N is still 12, P is still 0.4, but X is different. The statement here is at least. It's at least means 3 or more. So we're going to use the greater than or equal symbol because we want to include 3 or more. So just to summarize, you want to get familiar with the inequalities. When we say less, use the less symbol. When we say more, use the more symbol. If we say at least, I'm going to use the greater than or equal symbol. If we say at most, I'm going to use the less than or equal symbol. So familiarize yourself with the inequalities and the symbols. Let's remind ourselves of the formula. P of X equals N choose X times P raised to the X times the quantity 1 minus P raised to the N minus X. We'll plug in X. P of X is greater than or equal to 3. In this case, we have an inequality, so I'll put the entire thing inside the parentheses here. That means I want to find the probability of 3 plus the probability of 4 plus the probability of 5 all the way to the probability of 12. Remember, being greater than or equal to 3 means 3, 4, 5, all the way to 12. And that's a lot of calculations. That's 9 calculations, and I don't want to do that. So we're going to try to find another way to do this. So I want you to think about it. Look at our distribution. What's the total area under the curve? What is the total area? The total area has to be exactly equal to 1. So if I do P of 0 plus P of 1 plus P of 2 all the way to P of 12, this has to be equal to 1 because that's 100%. So this is too big. I just want to start from P of 3 all the way to P of 12, not starting from P of 0. So here's what I'm going to do instead. I am going to subtract from 1. I'm going to do 1 minus the stuff I don't want. And the stuff I don't want is P of 0 plus P of 1 plus P of 2. That's everything in front of P of 3. That stuff we don't want. So to calculate P of x being greater than or equal to 3, we'll just subtract from 1 P of 0 plus P of 1 plus P of 2. P of 0 is equal to 12 choose 0 times 0.4 raised to the 0 times 1 minus 0.4 raised to the 12 minus 0. P of 1 is equal to 12 choose 1 times 0.4 raised to the 1 times 1 minus 0.4 raised to the 12 minus 1. P of 2 is equal to 12 choose 2 times 0.4 raised to the 1 times 1 minus 0.4 raised to the 12 minus 2. Now, I would recommend you type in each one of these into a calculator. And I would recommend you do the entire thing in a calculator. When you do the second one, just go back and edit the original equation, and you will be able to calculate these other ones much faster. And so I have P of 0 is equivalent to approximately 0.00218. I have P of 1 is equivalent to approximately 0.01741. And I have approximately, and P of 2 is 0.06385. I'm going to do the inside of the parentheses first, and then I'll subtract that from 1. We have 1 minus 0.08344, and we'll finally get our answer. By subtracting from 1, we have the probability is 0.91656. So we have approximately 91.656% chance that at least 3 Americans will agree with this statement if we have 12 Americans selected. We did the work by hand, and you can see how much time it takes. In real life, we never do the calculations by hand. We use a statistics calculator. Please feel free to use that statistics calculator that I provide for you in the description. Let me show you how to do this on the statistics calculator. For part A, the number of trials is 12, so make sure you put n is 12. Our probability is 0.4, so enter 0.4 here for the probability. They use this symbol pi for probability. Now I want to be exactly 3, so I'm going to go in the between case, and I'm going to go between 3 and 3, which is equivalent to being equal. So when we want an equal case, make sure we're going between 3 and 3, which means exactly 3. Click recalculate, and then we will have our probability here. Our probability for part A is 0.1419. For part B, I want to look for at least 3 Americans, so I'm going to go in the between case again, because we're starting at 3, and we're going to end up with 12. So between 3 and 12 Americans. So we're going to click the between option and click recalculate. And that gives us a probability of 0.9166. And this calculator is nice in that it gives us a picture of what probabilities we're actually adding together. Now, from now on, we're going to just use the calculator to do these calculations, but I still want to be able to understand what's going on in the problem. So, in this case, we'll look for n, p, and x again. We have, let's read the problem. According to the U.S. Department of Commerce, 86% of all U.S. households have a cell phone. If 15 U.S. households are randomly selected, find the probability that 9 of them have a cell phone. In our case, n is 15 because we have 15 households that are randomly selected. The probability of success is 86% or 0.86 as a decimal. Now we have to be careful. We want to find the probability that 9 of them have a cell phone. So that's exactly 9. Recall the formula. P of x equals n choose x times p raised to the x times the quantity 1 minus p raised to the n minus x. We're looking for p of 9, and that's equal to 15 choose 9. I'm just plugging in n and x, and this is 0.86 raised to the 9 times 1 minus 0.86 raised to the 15 minus 9. And so we have p of 9 is equal to, I recommend using the statistics calculator for this, or your handheld calculator will work fine as well. We have 0.0097, so approximately 0.0097% chance. Let me show you how to do the problem on the statistics calculator. In this example, we have 15 trials, and the probability is 0.86, and I want to find exactly 9, so we're going to go to the between option and put 9 and 9 here, and that's the same thing as putting exactly equal to 9. Click recalculate, and here's our probability, 0.0097. And that's quite unusual because that's less than 5%. Example, it was found that 80% of all American victims of healthcare fraud are senior citizens. If 10 victims are randomly selected, find the probability that less than 4 are senior citizens. N in our case is 10. P is equal to 0.8, and we want to find x less than 4, so I'll use the less than symbol. This gives us P of x less than 4 is equal to P of 0, no Americans being a victim, plus P of 1, plus P of 2 plus P of 3, and that's it because we want it to be less than 4. So the probability of 0 Americans being a victim, probability of 1 American being a victim, plus the probability of 2 plus the probability of 3. Now we can do the calculation by hand by using the formula 4 separate times if we wanted to, but we can also plug this into our statistics calculator and calculate the probability. You can do the calculations individually and find P of 0, P of 1, P of 2, plus P of 3, but that's too much work. We can just type in the whole thing on the computer, and I'll show you that now. For the next question, we have the number of trials is 10, our probability is 0.80, and we want to find less, so I'm going to click the below option and change this to 4. We want less than 4, and so we'll click recalculate, and that gives us our probability of 0.009. So you could do this problem on a calculator. So our solution is 0.0009. So we have a very low chance of finding less than 4 senior citizens out of 10 that have been a victim of healthcare fraud. That's highly unusual. Example, 2 out of every 100 people who take Depakote to relieve their migraines, headaches, experience weight gain as a side effect. A random sample of 30 users is obtained. Find the probability that at least 2 of these users experience weight gain as a side effect. N is going to be 30 users. So that's our number of trials. P is our probability, and they didn't give us a percentage, but they did give us a fraction. 2 out of 100 is equal to 0.02. X is at least 2 successes, so we're going to use greater than or equal to 2. So I want to find the probability of X being at least 2, and that is equal to P of 2 plus P of 3 plus P of 4 all the way to P of 30, our last trial. Now you could definitely have some fun and do every single one of these 28 times, but that's not realistic. Most of us will jump straight to the calculator and we will do this problem on the computer. For this example, we have n equals 30 because there's 30 users, and the probability here is 0.02, and I want to be between because we're saying at least, so we're going to go, now we want to find our probability at least 2. So we have several different ways to do that. I can say at least 2 is the same thing as from 2 up to our last trial, which is 30. That's inclusive, so 0.1205. That's one way to do it. Or I can say at least 2 is equivalent to saying above 1. At least 2 is the same as above 1. I'll recalculate that, and I do get the same thing. So there's several different ways to approach it. Just make sure you're adding the correct areas together. If you wanted to do this problem by hand, you can do 1 minus the things we don't want, which is in the beginning P of 0 plus P of 1. So if I wanted to, I could do this by hand and subtract P of 0 plus P of 1 from 1 to find the probability. But nowadays we have technology, so we can just plug it into our computer. And that gives us a probability of 0.1205. There is a 12.05% chance that of 30 users, at least 2 of them will experience weight gain as a side effect. Finally, the mean and the variance of a binomial distribution can be computed as follows. the mean is equal to n times p, and the variance is equal to np times the quantity 1 minus p. And so we'll try an example. Let's toss a coin 3 times. Calculate the mean and variance for this probability distribution. The mean is equal to n times p. Since we're tossing it 3 times, n must be 3, and we know the probability of success is 0.5. So we have 3 times 0.5, and this gives us 1.5. And if you go back to our previous notes, we did get, in the long run, we had 1.5 heads on average. The variance is equal to NP, or 3 times 0.5, times 1 minus 0.5, and this gives us 0.75. And so we get the exact same answer as earlier by doing it with a different method. Just remember, this formula only works for a binomial distribution.